We now ask how the mathematical optimization methods we've developed will handle budget sets that are non-convex. We'll say for the appendix, for graph 6.14, the case of kinked budget constraints, and illustrate here what happens with a smoothly non-convex budget set. Such a budget set is created by a budget constraint that starts out steep and becomes shallower and shallower, and the consumer will still maximize utility subject to this budget constraint. The budget or choice set that emerges from such a budget constraint is clearly non-convex. Just take any 2 points that lie on the constraint, connect them by a line, and notice that that line lies fully outside of the choice set. Now remember what the mathematical optimization method will do. The method will find any tangency of an indifference curve with the budget constraint. One such tangency occurs at point A, where the blue indifference curve is tangent to the budget constraint. Another tangency will lie further out along the magenta indifference curve that is tangent to the budget constraint at point B. Since the mathematical optimization method picks out all tangencies between indifference curves which emerge from the utility function with the budget constraint, both A and B will be offered as solutions. In fact, it may even be that the mathematical optimization method will result in a third solution, one that has the magenta indifference curve tangent on the higher portion of the budget constraint. Of course, A is not a true optimum for this consumer, and therefore should be rejected as we think about the underlying economics. There is in fact a mathematical way to distinguish between points A and B. It involves checking what's called second-order conditions, which are second derivative conditions of the problem. But we can avoid doing this by simply checking to see how much utility the consumer obtains at the different bundles that's offered by the mathematics. In other words, we could plug bundle A back into the utility function to check how much utility bundle A actually gives the consumer. We could then do the same for bundle B and see whether one is higher than the other. Only the bundle that yields the higher level of utility is in fact the true optimum for this consumer who faces a non-convex budget constraint. If there are two optimal bundles, both of them will give the same level of utility and both of them will be solutions.